So you wish to observe the moon. Well, people have been observing the moon for centuries, so join the club. Actually, you're kind of required to observe the moon at least 12 times during the course of this semester. 10 times if it is summer semester. Alright, so we want to go out and observe the moon, and we want to take data. To record our data, I'm going to go into the lab for Chapter 5. Click on that and go down to the Moon Lab, Moon Project. And in here where there's possible worksheets, 3 of them. There's a Word version, Excel version, and PDF Adobe file. I'm going to choose the Word version just to get started. Open that. Here's what it looks like, and I'm going to start filling out this chart. My observing location is Calhoun, so I'm going to write that down. The date, I'm going to just say it's January 6th. And the time is my local time that I would find on my watch. Looking here, looks like time is 7:12 p.m. So I'm going to go with that, 7:12 p.m. Moon phase. If I look at the moon phase, looks like this moon is a crescent moon. I know that because it's less than half illuminated as I'm looking at it. So I have a crescent moon. Now I wish to clarify this a little bit. I want to know whether it's waxing or waning. How do I know if it's waxing or waning? Well, if I've been observing the moon over the course of several days, and I notice that it's increasing in size, then it's increasing in illumination, hence it would be a waxing crescent moon. On the other hand, if it has been decreasing in size from day to day, then it would be a waning moon. So just by doing the moon project day to day, I would find that out. Another way to do this is if I go back into the course here, if I go down into the external links and click on Moon Phase Calendar, I would get a calendar that shows the phases of the moon for my particular month. So this is always updated as to your particular month at the time. And if I'm here, I'm looking at January, and let's say January 6th. I indeed have a crescent moon on January 6th. And I can see that on the 5th, the previous day, it was less illuminated. And on the 7th, it is more illuminated. So it is increasing in illumination from day to day. And hence, I do indeed have a waxing crescent moon. So I'm going to verify that as a waxing crescent moon. Another way to know whether it's waxing or waning, if it's a crescent, is by looking at the moon. If the arrows of the moon are pointed towards your left, that means the moon is trailing the sun, and most likely you're watching that moon, you're seeing that moon in the evening time. So if those arrows are pointing to your left as you're looking south, then it is indeed a waxing crescent moon. Whereas if the moon arrows were pointing to the right, then it would be a waning crescent moon, and you probably are looking at that moon in the morning time. So that's another way to look at it. You can use the same general rule for a gibbous moon. If the moon is deficient on the left-hand side, then it is a waxing gibbous moon. And if it's deficient on the right-hand side, it is a waning gibbous moon. So that's one way to determine just by looking at the moon what kind of moon you have. Alright, our next measurement is the altitude. We wish to calculate or determine how far above the horizon the moon is in terms of angular measurement. And so we're just going to take this measurement. We don't want to carry a sextant or a protractor around. It's too wieldy, and we might even be somewhere where we just don't have things with us. So we want to just use what we have with us. And in particular, we want to use our hands. So what we're going to do for our degree measurement is we're going to use a hand span. And a hand span is actually from the pinky to the thumb is actually 15 degrees of measurement. So that is 15 degrees of measurement. And you may say that, some people have bigger hands than other people. So how do I know that a hand span is 15 degrees of measurement? That's a good question. Well, if I have a hand span, and if I have a large hand, then I probably also have a longer arm. So a large hand with longer arm is still subtending a 15-degree angle. And if I had a smaller hand, I probably have a shorter arm, and I'm still subtending the same 15-degree angle. So it works. Short arm, small hand, 15 degrees. Long arm, big hand, 15 degrees. Still subtending the same 15-degree angle. So it's actually a pretty accurate measurement. And just as a check, if I imagine a plane going straight out horizontally towards you like this, if I put my hand on that plane to start with 15 degrees, and then put another hand 30 degrees, 45, 60, 75, 90, my thumb is right above my head at my zenith. So that angle between there and there is 90 degrees. It's a right angle. And I took 6 measurements of 15 degrees to do that. So it's exactly on 90 degrees. So it works pretty well. Another way you can do a measurement is if you just use your fist, it is 10 degrees from the bottom to the top of your fist. So 15 degrees for a hand span, 10 degrees for a fist. And we can even further subdivide the hand span into 5-degree segments. From the pinky to my ring finger is 5 degrees. Ring finger to my index finger is 5 degrees. Index finger to my thumb, 5 degrees. So I have 5, 5, and 5. So we wish to make this altitude measurement. Now I may not know where the horizon is. There might be trees out there and I just can't see the horizon. So how do I know to make this measurement from a horizon that I can't see? Well, we're going to imagine that this plane just below your arm, that your arm would rest on, is the horizon plane. So if I were to rest my arm on that plane, put my pinky on that plane, then I'll make my measurement from that horizon plane. So as I'm looking at this, south direction here, and this horizon plane like that, going out like that, I got one hand span and a third of another hand span to get up to where the moon is. So I would say that my altitude for this moon is 15 degrees plus 5 degrees, or 20 degrees. East-west right ascension. We are going to make our own measurement for east-west right ascension, and we are going to make a measurement of degrees either to the west or the east of our south position. And we're going to do this. This will be unique for this project. I do not want you to find data located on the internet from the right ascension based on the vernal equinox and so forth and so on, because in the sense that's kind of cheating. I want you to be able to make this measurement and prove that you've made this measurement yourself. So we're going to make this measurement from our south direction. And as we're going from the south direction here, as I'm pointing south here, I'm going to make the same hand span measurement, 15 degrees per hand span, over from the south direction. And it looks like the moon in this particular case is one hand span over from the south direction. So, and it's to my right, so that's west as I'm looking south, and to my left would be east as I'm looking south. So right is west, left is east. So this is 15 degrees west for the right ascension. All right. I want to convert this measurement of right ascension into a time. Now, I know that 360 degrees of a circle is divided into 24 hours of time. So for every 15 degrees of measurement I have is 1 hour of time. And for every degree of measurement I have is 4 minutes. So I'm making that conversion. As I'm looking at the position of the moon, it's already west. And the moon travels from east to west on any particular night. So the moon is already past my overhead meridian position. It won't get there again tonight. And in fact, 15 degrees ago, or 1 hour ago, it was on my overhead meridian position. So what I want to do is, if my measurement is west, I want to subtract that time from my local time in order to determine the time on the overhead meridian. So 15 degrees corresponds to 1 hour. So I would say that my time on my overhead meridian is 6:12 p.m. Alright, so I got my first line of data. I'm feeling pretty happy about that, but I have to make 2 more corrections. I have to worry about daylight savings time and my position in the time zone. First one, daylight savings time. If we're on daylight savings time, which is spring ahead and fall back, if you're on daylight savings time, the local time of your clock has already been moved an hour ahead of the astronomical time. So we need to subtract that hour. If the dates of your measurement is between April and November of the year, then your local time is 1 hour too far ahead. So we need to subtract an hour if your measurement's at that time of the year. In this particular case, my measurement's January 6th, so it's between November and March, and I don't have to correct for daylight savings time, so I don't have to subtract that hour for daylight savings time, so we're okay at 6:12 p.m. for that. Alright, the other correction is for our location in the time zone. We want to say that in the central time zone, it's located right on 9 degrees west longitude, but Huntsville and Decatur are located at 86 degrees west longitude, so we are 4 degrees off of the central meridian of the time zone. So to account for those 4 degrees and 4 minutes per 4 degrees, 4 times 4 is 16 minutes. So we need to add 16 minutes to all of our measurements across the board. And all of our measurements will have this addition of 16 minutes added to it to account for our location in the time zone. So we're going to add 16 minutes. I'll make this 6:28 p.m. and that is my time on the overhead meridian. Now for a waxing crescent moon, I would normally expect that to fall on my overhead meridian between 12 noon and 6 p.m. So this time is a little bit off. 6:28 p.m. is pretty close to a first quarter moon, so I'm not feeling too bad about that measurement. I'm just about an hour off. So I'm going to keep it. But one reason I might be an hour off is because maybe my south direction wasn't correct. Maybe I didn't quite have pure south. And how do I determine south? Well, the best way is to get a compass and measure south, or a GPS device if you happen to have it. Most of the smartphones have a compass built right in, and so if you hit a compass app, you can set the compass app up, and it looks like my south should have been a little bit this way. So right, that direction is south, which means that my measurement for my right ascension should have been a little bit more than it was, which means I would have subtracted more time, and that would have put it less than 6 p.m. and hence, so I really should have found my correct south first. And if I had used this south, all my measurements would have been off by that extra hour or so. So that's one thing you want to do, is find out where your true south is. If you don't have a smartphone, you don't have a compass, you can use some of these roads, like Highway 31 here behind Calhoun runs pretty much north-south. Highway 65 north-south. The Parkway in Huntsville, pretty much north-south. County Line Road is exactly north-south in Madison. So you could use these roads to help you determine your north-south direction. All right, so there's south. Got all my data. Great. I'm feeling good about myself. Just a word of caution. If you're making these measurements at home, make sure the neighbors aren't watching. Because if you're doing this kind of stuff, they're going to think you're a little bit goofy. Hopefully the neighbors aren't watching you too much. Hopefully they're not watching you at all. But if they are, then you want to kind of do this more discreetly. Once you get all your 12 items of data, and you fill out this chart, you want to save it. And when you save it, go up here and save as. We want to save it as a PDF file. So we're going to save it as a PDF, and then just save that. All right, publish it. And so now I have a file that I can send through the internet, because Word files, Excel files are not so good in sending as attachments, but a PDF file is great. It's just a picture of the file. So I can attach this to a message or an email, send it to Dr. Golben, and Dr. Golben will get it, so you don't have to personally hand it to me by 5 p.m. on the last day of the semester. And that's when it's due, 5 p.m. the last day of the semester. All right, so once you send that, you're done. Moon project done. Feel good. Go out and enjoy this. I hope you will enjoy looking at the sky as a consequence of going out and looking at the moon. Try to get your data, start this early, because the weather might not cooperate. So there are going to be days when the moon's out there, but you can't see it because of the weather. So try to get this done early in the semester so you can get as many measurements as you can over the course of the semester. You should be able to get 12, no problem, but start early and have fun.